So here we're looking at measuring enthalpies of reaction, specifically enthalpies of neutralisation today. Rather than use the data logger method that we used last time, where we were looking at producing a cooling curve, we're going to do a slightly more straightforward method in that we're just going to be using our thermometer to look for the highest, or in another scenario, lowest temperature reached during the reaction. So we're going to make sure we've got the temperatures of our acid and our alkali for our neutralisation here before mixing, and then monitor the thermometer and record the maximum temperature reached. What we're going to do is have a look at a series of different acids. So we're going to look at hydrochloric acid, nitric acid, and ethanoic acid. We're going to react all of those with sodium hydroxide in turn and calculate the enthalpy change for neutralisation for each. Later on, when you're doing your questions, you need to consider the percentage uncertainty in each of the temperature rises. So if we just have a look at the thermometer I'm using here, I think that's sufficiently focused, we can see that our big increments there are 2 centimetres cubed apart. So here, then we've got our kind of medium one, 1 centimetre cubed, and then if you have a look, we've actually got tiny increments here going up in 0.1 centimetre cubed intervals. So there is some information on your sheet, but you just need to think about how accurately you can record each temperature reading if your divisions are 0.1 centimetres cubed apart. And then the implications in terms of calculating your uncertainty. So what is the uncertainty in each measurement there? So in terms of the experiment itself, we need to start off with 50 centimetres cubed of our hydrochloric acid. And I'll just use a dropper to get this to the right level at the top. I just think we need to take some out rather than put it in. We did need a bit, there we go. I'll double check that once the bubbles have disappeared there. We've got 50 centimetres cubed of sodium hydroxide that I've already measured out. So we're going to put our acid into our polystyrene cup, supported by the beaker so that it doesn't fall over, and we're going to put the thermometer in there and monitor the temperature and record an initial temperature of our acid. We then need to do the same for the alkali, so we've got the temperature of each before mixing, and then we will mix them together. So this is reading 17.40 degrees there. So I'm going to dry that so I don't cause any reaction in transferring into my sodium hydroxide. These have both been sitting in the lab for a few days, so they ought to be at the same temperature, but we'll just double check. Yeah, so 17.4 on that one as well. Okay, so we take that out. Then we need to add the alkali to the acid, and then we're going to stir during the reaction gently and monitor the temperature change. It's about 29 degrees at the moment. Okay, so 29.60. I'll keep an eye on this. Doesn't appear to be shooting up further, so it's just always just watching and recording the most extreme temperature reached. Okay, in terms of the method itself, the next step then would be to rinse and dry our apparatus here, and then to repeat the experiment, changing for a different acid. So I've done that already for you. So in a second on the video, there will be a photograph of a set of results. So you need to record your results in your results table, and then work through on the practical sheet the results section, and then have a look at the questions too.